Once the system is been put on the network properly, you can connect to it via any web browser. Just put the IP address into your web browser and you'll get a login box like this. The default login name is system and the password is SANBlaze with a capital S-A-N-B and a lowercase l-a-z-e. Once you log in, you will get to this main home page that shows you information about the system, the IP address, and things like that. The easiest way to get started is to first go to the Express Manager page on the left. Clicking on that will load a page that shows you a kind of a graphical representation of the system. In this case, we have our RM4 system connected with 16 drive slots, so we have 16 drives here shown in the top column, in the top row I mean. If the drives are populated, they'll show up green, empty slots are white. If a dual ported drive has been inserted, you'll see both paths represented on top of each other like this. So in this case there's a dual path drive showing up in these two slots. The easiest way to get started is to select the drive you want to run a test on or get more information on. So in this case I'll click on drive 1. And then if I scroll down, you'll see our certified by SANBlaze test suites at the bottom here. You can then select what type of test you want to run. You can select the entire suite if you want, or specific tests. If I expand one of these, you'll see there's different levels of tests. There's level 1, level 2, and some tests have a level 3 option. Level 1 is a simple test that every drive should pass. Level 2 is a little more advanced, maybe doing data integrity testing, things like that. And then level 3 are more in-depth tests that could potentially cause drive issues or bring out problems, doing various sorts of more nefarious type testing. So depending on what type of test you want, they'll have different levels here. You'll notice in this case the level 2 ones are grayed out. You'll just have to enable here in the action section what levels you want to allow. So it will give you a warning indicating you may run into problems and things like that. So in this case I'm just going to expand this and I'll just pick some basic NVMe generic tests. If you select all of them, they'll show you on the side here which ones you've selected and what you can then apply to your test suite. So in this case I'm going to apply it to controller 101, which is the device I selected. It has one namespace, so it'll apply to that. And then it tells you how many number of passes you want to run each test, and then the time. In this case, these are tests that don't really run for a specific time. They just do one command and exit, so it doesn't really apply here. So if I hit add, it'll go ahead and put these into my test suite. Once the page refreshes here, you'll see at the top here there's a list of right now it shows 5 tests, but then there'll be multiple pages. I could show all of them here with this drop down. So if I expand that, you'll see more tests, all the tests listed in the suite here. Once the tests have all been added to the list, I can select them all and kick them off, or you can just select certain ones if you only want to run 1 or 2 of them. In this case I'll just start the whole suite, so I'll come up to the top here and click the starting action. This will go ahead and start the tests. You'll see they're running down here. It tells you which ones have completed and passed. You'll get things like a start time, end time, things like that. So if any of them get skipped, you'll notice some got skipped, so afterwards we'll look at the report and see why that may be. A lot of times maybe the drive doesn't support certain commands and things like that, so the tests are just marked as skipped since they're unsupported by the device. So we'll go ahead and let this finish. Okay, now that the testing is complete, you'll see we have a bunch of past tests, some skipped ones, and then one that had a warning. So now we can get kind of more information about what may have happened in some of these cases. So we have a built-in report. You can click here, and that'll generate it'll pop up a screen here showing a drives information about the tests. By default, it's just a summary here. If you want more detail, you can click this detail button, and that will bring out all this other information. So this is a per test kind of verbose information about what may have happened. So if we can scroll down, we can find the one that was skipped. So for example, here's some examples of skipped test. So in this case, this drive didn't support this particular feature, so the test was skipped. So a lot of the times you'll see things like that. Here's one that had a warning command. This tried to read an optional log page and it failed. So since it's optional, it's marked as a warning. So you can get information through this full report like this. This is for all the tests. If you want just a particular test, this one you can just click on the link, and it pops up just a report for that one particular test. So this one ended in warning. So if we go down, you'll see the information here, and it has a quote from the spec about what the expected behavior was, and why the command failed or whatnot. So down at the bottom here, you'll see a graph of IOs per second. Since these were simple tests that just did one command, it's only doing a couple IOs. You can mouse over it at any point and also read the power that the drive used in green. So you could tell if the drive's power was fluctuating as testing was going on. If you click the tabs here, you can also see bytes per second that were written or read, as well as a tab for drive latency. In this, again, these were not very I/O intensive scripts that I ran, so you don't see a lot. And probably the same thing with the latency as well. So again, you can kind of mouse over it and see what percentage reads and writes and things like that occurred. Some additional things you can do from this page. On an individual drive, there's remove buttons, so you could hot plug the drive in and out. If a drive has a quarterizer in it, you have additional features to pull the drive physically out. It'll turn the power off to the device, or glitch different signals. You can configure all this if you have a quarterizer. In the left-hand menu, you'll see a quart setup options. You can expand that and then click on the riser, and it'll load up a page here where you can pull the drive out, plug the drive, do it in a loop, as well as it lists all the drive signals here. And you can control if you want to glitch them, and their timing when the drive is hot plugged into that slot. So you can control all that from this page. Some additional features: the drives that you have connected in the system that we had are 3 drives and 2 drives and a dual ported drive. If you expand this init NVMe port in the left-hand menu, you'll see another representation of those devices. So these are our 3 base drives that we had, and then if you expand these, you'll see the namespaces underneath them. You'll notice these 2 namespaces have little arrows indicating that they have multiple paths. So this is our dual ported drive. If you click on that, you'll notice the device path section lists the 2 controllers and the namespace. So you can go kind of back and forth between them. This is a way to run additional tests outside of the certified scripts that we showed you earlier. You can get information, more in detailed drive specific information here, serial numbers, capacity, things like that, as well as the ability to run various I/O tests with more in-depth kind of control over all the features, and ability to tweak a lot of the settings, ability to do read, write, compare, tests, and different percentages of the reads and writes. So the separate video explains all those testing parameters more in detail, but this is how you would access those, as well as the ability to do any sort of other NVMe command via the generic I/O tab. So you can send off individual, read, write, reservations, as well as MI type commands as well, and then perform actions on the device such as doing resets, aborts, namespace management, things like that. If you go up to the controller level, you can do the same sort of testing to all the namespaces if you had multiple ones underneath the controller, as well as take different actions and do shutdown controller, take links up and down, do PCI resets, NVMe subsystem resets, things like that. So a lot of flexibility here as well. Some additional information you can also look at is there's a tracing feature on the left hand side. If you click this, you can configure what kind of commands and things you want to trace, and you can get a summary of them right here. The configuration you'd be done on this trace configuration page, you can decide if you want to trace just errors, non-read write I/O, or everything, and then you can turn on details for more information to get logged into the trace as well. Once that's all configured, if you go to trace view and click start tracing, it'll start logging all this stuff the next time you run any sort of tests, and then you can see the I/O summary here. And here's an example of kind of the output that you can get. Back in the Express Manager, if you went down to the certified section, we have support for VDM scripts as well. So those would be under the NVMe MI section, level 2. So there's a bunch of scripts for testing VDM if the device supports it, as well as the RM. As mentioned in the previous video, you would need special hardware that supports VDM, as well as a license to allow these tests to be run. We also support ZNS testing, so we have a full selection of ZNS test scripts here to test that feature of the NVMe spec, again, if the device supports it.
Hopefully this gave you a better understanding of our hardware and software. Feel free to contact our customer service if you have any further questions.